Hey everyone. So today we're going to be looking at parabolas again, and we're going to be specifically looking at some different ideas here. I guess that wasn't very specific, but let me show you. I think it's better just if I show you. So we have a parabola here, and there are 2 points that we're going to be looking at today, or 2 ideas that are a little bit different or a little bit new. So every parabola or every quadratic function has what's called a focus. So a focus is just a point that is somewhere directly above the vertex, and that's what kind of controls how narrow or how wide the parabola is. Now, so this is what's called a focus. Okay, a focus. And it's just a point. So, for example, we could say this point is, let's say it's 0, 2. I'll write that in there, 0, 2. Okay, that's supposed to be a 2 in there. And then equally far away from the vertex, we're going to have a line down here. And we call this line the directrix. Directrix. Okay, so the distance from the focus to that vertex is the same as the distance from the vertex to the directrix. So those are equal distances in there. So that means that this line down here, the directrix, might be something like y equals -2. So notice if our focus is 0, 2, then that would mean that our vertex might be 0, 0. And so our directrix would be down there, -2. So we would say there's a distance of 2 between the vertex and the focus, and between the vertex and the directrix, the same distance. Okay. Now, one equation we're going to be using quite a bit is what's called the distance formula, and it looks something like this. Y equals 1 over 4p x squared. 1 over 4p x squared. And so that p right there is going to be equal to the 2 in our focus. So for our focus, that 2 is our p. So we could say the focus is at the point 0, 2, or 0p. Or we could say that the focus is a distance of p from the vertex. So focus is p away from vertex. Alright, it's that distance p away from the vertex. So if we can figure out what p is, then we would be able to determine what where our focus is. So let's look at an example here. So we're going to use that distance formula, and we're going to write an equation for this parabola. So notice that the focus is at 0, -8, so our p in this case is -8. So we could write this equation. We could write y equals 1 over 4p. P in this case is -8. X squared. Now, we do need to make sure if we're going to use this formula exactly like this, that our vertex is at 0, 0. But we can see that it is because if our focus is at 0, -8, and our directrix is at 8, remember that they're equally distanced away from each other. So the midpoint between -8 and +8 is 0. And we already know the x value is 0. So the origin has to be the vertex. Now we can simplify this a little bit. We could do 4 times 8. So we would have y equals, and that's a negative, so we'll have -1 over 4 times 8 is 32 x squared. So this would be the equation for that, that situation where we have a focus at 0, -8. Okay. Now for number 2, we would do kind of a similar idea here. So they tell us the vertex is at 0, 0, and then we have a focus up at 1. So we could do our equation, y equals 1 over 4p. In this case, our p is 1. It's supposed to be an equal sign. So 1 over 4p x squared. So our equation is just 1 over 4 x squared, because 4 times 1 is just 4. And there's our equation. All right, so that's kind of how we can write equations based off of our what our p value is. All right, now on these problems, we're going to identify what is the focus, the directrix, and the axis of symmetry, and then we're going to attempt to graph the equation. All right, so to do this, we know that that -2 right here, and actually we should solve this for y first because we need it to be in that right format where it's y equals. So let's go ahead and do that. So we'll have, actually, could we switch sides first of all? Because I know some of y'all like to do that. So we'll have -2y equals x squared. All right, now let's divide by -2. So we'll have y equals, if we divide by -2, we'll have x squared over -2, or we could write it like this, -1/2 x squared. Right, if we divide by 2, remember there's an imaginary 1 in front of the x squared, so we could do 1 divided by the -2. All right. So now we know that this thing out front, the -1/2, has to be equal to our 1 over 4p. Remember what we were using up above? Remember that our distance formula, this number out front right here, this number out front right here, 1 over 4p, look what it is in our problem down here. This is our 1 over 4p. So let's set that equal to -1/2 is equal to 1 over 4p. And then we can solve 4p. So one thing we could do here is we could invert both sides. So we can get a -2 equals 4p. That's something we can do in algebra. All right, and then to get rid of that 4, we could divide by 4. So our p is just going to be -2 divided by 4, which comes out to be -1/2. -1/2. So our p in this case is -1/2. All right. Let me make sure that we're good here. Looks like we are. Okay, so our p is -1/2. So that means that our focus is going to be 1/2 up above our parabola, or up above our vertex. So the focus should be 0, -1/2. That should be our focus. Okay? That's our focus. So if we were to graph this on here, actually that would be really difficult on this graph if it's -1/2. It should be right in here somewhere. That's our focus. So our directrix will be a line right on the other side of that, equally distant from the vertex, which in this case, the vertex is at 0, 0. And if you're not sure where the vertex is, remember, guys, you can plug that thing into Desmos if you want to figure out where the vertex is. Anyway, our directrix is the same distance up above, so we could say that our directrix is going to be y equals +1/2. So that's our directrix. So if our focus is -1/2, 0, -1/2, then our directrix is y equals +1/2. And then finally, we want to find the axis of symmetry of the parabola. Well, if we graph this, we'll see our parabola kind of looks like this. Okay? And so the axis of symmetry, remember, is just the it's just the x value of our vertex. So the axis of symmetry here is just x equals 0. Axis of symmetry is just x equals 0. All right, let's look at one that's a little bit different here. And I guess we're getting lots of practice here. So let's do this. One thing that we need to realize about this problem is that our vertex is not going to be 0, 0. First of all, notice that our parabola goes to the left 1 and then down 3. So our vertex is right in here. So just keep that in mind. Vertex is right about there. Now let's try to figure out where the focus is. So we could take that -2 out front and set it equal to 1/4p. All right, and then we're going to solve for p. So again, we could invert both sides. We'll have -1/2 over here, and we'll have 4p on the right. And then we can just divide by 4, so p will equal -1/8 when we divide by 4 over on the other side. Okay, so if our p is -1/8, that means that our make sure I'm getting this right. Yeah, that means that our focus is going to be -1/8 away from the vertex. So our focus is going to be negative. Well, let's see if I can draw it in here. This focus here is going to be -1/8 away from the vertex. So it'll be down 1/8 from that vertex. So if the vertex is at, let's see, that would be -1, 3, and we're dropping the focus down by -1/8. Did I do that right? It's -3. Okay, so if we do that, then it's going to be, the focus here is going to be -1, -3, and 1/8. Because we start out at -3, and then we drop down another 8. So we're going to go down -3 and 1/8. So that is our focus. The directrix is going to be 1/8 on the other side. of our vertex. So it's going to be a line right up in here somewhere. So we could write that as y equals, so if our y value for the vertex was at -3, then it'll be 1/8 back towards the origin. So it'll be -2 and 7/8. -2 and 7/8, because we subtracted 1/8 in the other direction. All right. So that's our directrix. And notice that this and this are both 1/8 away from our vertex. So if our vertex is -3, they're both equally distant away from that -3. So we have -3 and 1/8 down, and then up above it we have -2 and 7/8. All right. Okay, last thing we have to do is the axis of symmetry, and that is just x equals whatever the x is in our vertex, which is -1. All right, so there we go. All right, let's look at, we're not going to do number 7, so just ignore that one. Let's just look at number 6 here. We're going to write an equation for this parabola. So this is kind of what we did before. We're going to do y equals, the origin is the vertex here, so we don't have to worry about that. And then remember that it's going to be 1/4p. Our p in this case is going to be, looks like 5, right? It's 5 away from the vertex. So it's going to be 1/4 times 5, x squared. So 1/4 times 5x squared is 1/20 x squared. And that is our equation for this parabola. So there we go. Well, guys, really the only way to figure this out is to practice it, just dive right into it. So work a few examples on your own. I'm going to be giving you all some examples that y'all could work. So let me know if you have any questions about it, because I know it's a little bit to take in. Once you do a little bit of it, then I think you'll catch on pretty quickly. But guys, that is all for me today. Thank you guys for watching, and I'll see you all in the next video.